Okay, so in this video, we are talking about learning models. So how is data used basically to teach computers to perform different tasks? Um, Type of problems solvable through learning from data. I mean, there are four different kind of modes of learning, and any problem that falls under data science will fall into one of these four modes. One is called regression, also termed, this actually appears in the umbrella of supervised learning. We will discuss this regression in detail just in a while. Another mode of learning is classification. Both regression and classification, they fall under supervised learning. And another mode is clustering. Basically, that actually falls under the unsupervised learning paradigm. And last is reinforcement learning. So whatever your data science problem is, whatever your modeling is, whatever your query is, whatever you want to predict from your data, whatever attribute you are interested in, your problem will fall into one of these categories. Either it will be a regression problem, or it will be a classification problem, or it will be a clustering problem, or maybe it's a reinforcement learning problem. So let's discuss each and every of these four categories one by one in a bit detail. So let's start by regression. In regression, let's say you are available with a lot of your data has a lot of attributes. Let's say attribute 1 x1, let's say attribute 2 x2, attribute 3 x3, and let's say a lot of attributes, let's say xt. And maybe there is some attribute that you're interested in, sometimes called the target attribute y. Assume all these attributes are just real. So real attributes, I mean, x1 is some real number, x2 represents some real number, x3 represents some real number, and all that, and this y, which is our target, also represents some real number. So for example, it completely depends upon your business, what kind of attributes you're recording and what kind of attributes you might be interested in. For example, if you're working in let's say your business is property or a real estate business, or maybe a house building business or stuff like so, x1 might be the area of a particular house, x2 might be the total number of rooms in a particular house maybe, or a building, x3 might be some other feature that is available in the house, and xd there may be d features, and y, you may be interested in the price of that house. So one of the attribute might be the location of the house and stuff like so, and you may be interested in price. So maybe you have a lot of records from history, maybe last 10 years or maybe last 50 years. You have a lot of records and you have prices, and now you really want to decide that for maybe a new house, you would really want to decide, let's say you want to purchase a house and later you want to sell that house out. Let's say you're just assuming the features. Let's say that you're just seeing the features for that house, that the area is this much, the number of rooms are these, and all these values are this. So you'd really want to predict what will be the price of that house. So you may really want to build a model that actually map these features to the price value. And this precisely is what we call regression. This appears in supervised learning framework because we actually supervise our learning paradigm by supplying these target values first, and then we really, once the mapping has been learned, then we are able to actually predict these kind of attributes. So all these are attributes, and this is target attribute. The target attribute may be more than one attributes. As long as the target attribute is real, the paradigm is really called a regression. Here I've just given you example of regression with, let's say you have just one attribute, maybe x1, and you have one target attribute which is just y. And let's say all these blue points, they are actually the previous history records, that when the feature value x1 was this, at that time the price was this much. When x1 was this, then the price was this much, and so on. So this is the previous data that is available. It's a two-dimensional data. And let's say you want to fit a model, you want to learn a model that actually relates x1 to relate your attribute x1 to the target attribute y. And in this particular case, this particular model is linear. As long as your target attribute is some real valued attribute that does not have predefined categories or finite number of categories, the model you are working in is regression. And regression is basically the model that most of the companies, most of the organizations, most of the businesses, they mostly have regression problem in their business. The queries they really want to answer, they actually fall under this regression paradigm. And again, these attributes, the target attribute, it may be one attribute, it may be a lot of attributes that you want to predict at once. And the data or the available data, even if it is not in the numeric form, even if it is not real numbers, it is in text form or in records form or in JSON objects or whatever, there are ways to convert the data, there are ways to prepare the data first to convert it to a numeric form and then apply whatever model you want to apply, for example, regression. So in regression, we are given a set of attributes. Let's say all that set of attributes is x and a target value, and we want to really learn a function that maps x to y. And this y value, the target attribute, may be a vector of values. In that case, the regression model is called a vector regression. In classification, however, we are again given some attributes, let's say x1, x2, dot, a lot of x attributes, and a target label. But here this target is a class attribute, it's a category. For example, all these attributes, they may be attributes of an image, maybe the pixel values, maybe the mean intensity, maybe the gradients, and maybe a lot of features maybe for an image. And this might be the class label of an image. Maybe it's a vehicle image, it's a pedestrian image, it contains this kind of content, it contains that kind of content. So if your label, y label, if your target label or the target attribute is categorical, then we will call this kind of supervised learning problem as classification. Again, you have some set of attributes or features called x. You want to build a function f on that maps this to predefined classes. Here y is the set of attribute, y is basically y is no longer a real number, it is not some real value to predict, it is basically a category label. And to describe here, let's say we have two features, let's say x1 and x2, and let's say the color of all these data points is just let's say the color of different data points, let's say that is class label. So for example, this is class 1, all this is in red. This is class 2, let's say it is all in orange, and this is class 3, it is all in yellow. And we have two features here, x1 as an attribute, x2 as an attribute. So the goal really is to come up with a function that actually differentiates, that actually draws a boundary between different classes. Maybe the boundaries are like so. If the target is really this categorical, it has predefined classes, then this problem is really known as classification. And a lot of problems, for example, face recognition, that this face recognition falls under classification, this image recognition that falls under classification. A lot of problems in industry are really of classification. Although we have seen regression in which the target is continuous and we want to learn a mapping from feature attributes to target attribute. In classification, we again want to learn a mapping from features attribute to target attribute. In classification, the target attribute was categorical. What if the target attribute is no longer there? What if you have set of data, let's say x1, x2, x3, a lot of attributes of the data, and you have a lot of records of the data, and you just want to group the data in different groups. Where you're not interested in a particular target label, but rather you are interested in what kind of data records they are similar to each other, and what kind of groupings are there. This kind of learning paradigm is known as unsupervised learning, because the target label is no longer there. The target label Y is no longer guiding you, and you are not basically finding out a mapping from source attributes or feature attributes to target one. Rather, you just are interested in grouping. Here, for example, this is one group. And that group may be based on some kind of similarity functions that is defined among different records. So for example, you have record 1, x1, let's say record 1, let me denote the record 1 as R1. It is basically some values x1, x2, and in this particular case we have just two features, let's say x1, x2. So that is, let's say, record 1. We have record 2 with again some values. We have record 3. We have a lot of records, and we want to make groups of these records, and let's say we want to make 3 different groups. So to make the groups, to make the clusters of all the data, let's say, first we need to know what number of clusters we are interested in. That is sometimes called a hyperparameter. We have to give this parameter one way or the other. Once given that, we have to define a similarity function that actually gives the similarity among records. And this similarity function can be as simple as Euclidean distance, or it may be as complicated as maybe the distance between two strings, or DNA sequences, or whatnot. So once the similarity function is defined, that actually gives a similarity score between two data points or two records. And once we know the number of clusters we want to make, actually this clustering algorithm makes the groupings. And once the groupings are there, we can actually have a closer look into the data and see the patterns of the data among different groups, and what are the characteristics that actually differentiate data points from one group to another group, and so on. Sometimes this clustering is also used as a pre-processing in regression or classification model. Particularly in classification, sometimes clustering is used as a pre-processing, and sometimes the clustering is used as a post-processing to remove the noise in the classification algorithm that actually produces the labels. For example, just think about that a classification algorithm just assigns these two data points a different class. Then maybe a clustering algorithm rectifies that based on the spatial locality of different features and the classes. So clustering alone itself has a lot of applications, and clustering itself is used sometimes as a pre-processing or post-processing of other different kind of learning paradigms. Next, we talk about reinforcement learning. In reinforcement learning, that's basically different than supervised learning, although it looks like so, but it is different than supervised learning. What happens basically is you have some agent, basically it actually acts in environment. The agent has a set of actions to perform at a particular state. So for example, let's say a vehicle is moving on the road, and the vehicle is your agent, and all the things, including road and the other vehicles and the wind and the atmosphere, all these things they collectively define an environment. Now at a particular state, for example, the vehicle has to decide a set of action. Maybe the action might be to accelerate, maybe to switch lane, to apply brakes. There are some set of actions. And in that particular state, the vehicle or the agent has to choose one of the available actions. Once the action is chosen, the action actually changes the environment. It basically affects the environment, and the environment changes. Once the environment changes, you observe the new state, and you also get a reward. The reward might be a positive reward, it may be a negative reward depending upon what you have done. For example, the vehicle just decided to switch the lane, and after switching the lane, you may get an empty lane, and you actually get a speed up in your journey. And in that case, the local reward might be really positive, the speed up in the time. But globally, if your goal is to reach at a particular destination, then maybe this local reward that looks like positive may become harmful, because that lane may go stuck in the next state, and you actually lose much more amount of time. You actually got more late than that. So what happened really is, particularly in game playing and report planning and self-driving cars, all that, you place an agent inside the environment, and the agent acts. There is a goal where you want to reach. The action may be good or bad. Locally, you may think an action as good, but if it leads to the goal efficiently, then its reward is called as a positive reward. Otherwise, globally, it's a negative reward or maybe a bad thing. So the agent chooses an action, acts on environment. If a sequence of actions leads to the goal, in the vehicle example, for example, if leads to the particular destination, then we will call those sequence of actions, sometimes called a policy, as a good policy. If a sequence of actions, or maybe one or maybe a few of the actions on the sequence, they actually do not lead to the goal, then we may have to play the game again, or we may have to go to the environment again and choose different actions in those kind of states. And once playing again and again and again and acting again and again in the environment, we actually start learning what actions or what sequence of actions are good in this particular environment. Remember, until you reach the goal, you do not know which action you have performed so far is better. But if you perform the same game again and again for some kind of actions, you build a confidence that these actions are good. And the sequence of action, you basically learn the sequence of action to reach a goal, and that sequence of actions is called a policy. And this precisely is the difference between reinforcement learning and supervised learning. In reinforcement learning, the actual label, whether you reach the goal or not, it is not supplied at the action time, but rather when you reach the goal. So the availability of the target label is delayed at the goal rather than at the action time. So yeah, this wraps up this video. In the next video, I'm going to talk about some software support, some cloud services that are available, and some kind of general pipelines of any kind of data science project. So thanks for watching, and see you next time.